Okay, example 2, same deal. All right. Quantity of ideal gas had initial values of all that. Find P sub 2 if the final volume was that, the final temperature was that. Solve the equation for P2 as the first step. So again, it's ideal gas. Just like before, if anything's held constant, throw it out. So if volume's held constant, P1 over T1 equals P2 over T2. That's still true. In this case, nothing's being held constant, so all three variables are alive and well. P1 V1 over T1 equals P2 V2 over T2. Cross multiply gets me P1 V1 T2 equals P2 V2 T1. I want to get P2. Solve for P2. So if I divide both sides by V sub 2 T sub 1, just like that, I got a formula for P2 only. And once again, I'm just going to work it out then. So P sub 2, what I'm looking for equals big fraction bar. Initial pressure. Something that hopefully you'll get accustomed to is some of these units that are being used. Volume is going to be cubic centimeters, cubic meters, liters, that kind of stuff. Cubic inches maybe. Volume is going to, or sorry, pressure is going to be atmospheres. The last one was atmospheres. Pounds per square inch. PSI is another way of writing pounds per square inch. Let's see, what's another one? Newtons per meter squared. Let's say again. Newtons per meter squared. Yeah, newtons per meter squared is another one that's come up quite often. So start getting accustomed to these types of units to understand what's what. They usually go pressure, volume, temperature. If they don't specify anything, assume pressure, volume, temperature order. That's how they usually give them to you. And temperature again in kelvins, which it has to be kelvins. At some point in the near future, they're going to throw it into Celsius, and we'll have to convert. So just be careful of that. The Celsius ones are going back to the more reasonable numbers, like 150 and those kind of things. So anyway, so P sub 1 is 0.003 times 10 to the 14th. V sub 1 is 0.007. T sub 2 is 0.003 times 10 to the 7th kelvins. V sub 2 final volume was 3 times 10 squared. And the final initial temperature is 7,000 kelvins. So just like that, we can get all of our numbers in there. And then it's just a matter of, again, using our calculator. So 0.003 times 10 to the 14th times 0.007 times 0.003 times 10 to the 7th gets me 6.3 times 10 to the 13th for the top. For the bottom, I do 3 times 10 squared times 7,000. That comes out to 2,100,000. And then finally, I just type in 6.3 times 10 to the 13th divided by 2,100,000. And we get 30 million. Okay. That is a pressure, right? And pressure is in the unit of pounds per square inch, so pounds per square inch. All right, so again, your calculator is doing all the grunt work for you. It's up to you to get the correct stuff written down. And again, solving for the variable first and then substituting in makes for a much friendlier problem than to throw all the stuff in this form and then cross multiply with all these scientific notation looking numbers. It's just much easier to get the answer first, throw all the numbers in, and then your calculator can work it all out for you.